Imagine a journey, not across space, but back through time, to the very beginning. Picture yourself moving not just through the vastness of the cosmos, but through the ages, retracing the steps of existence itself. We're about to travel to a moment before anything we know existed, a time before stars, before planets, before even the concept of space as we understand it. Before Earth, before the Sun, before even the Milky Way, everything was compressed into a single, infinitesimal point. This wasn't just a small object, it was the totality of everything. All matter, energy, space, and even time itself, squeezed into a spot so tiny it defies imagination. This point was unimaginably hot and dense, a cosmic seed containing all that would ever exist. Temperatures soared far beyond anything we can create on Earth, and the density was so extreme that the laws of physics as we know them break down. From this one point, the universe was about to burst forth. In a fraction of a second, everything would change, the birth of space, time, and the very fabric of reality itself. How could the vastness of space fit inside something smaller than an atom? It seems impossible, almost magical. But this isn't just a story, it's what science tells us based on decades of observation and theory. Astronomers discovered that galaxies are rushing apart, as if from a great explosion. The farther away a galaxy is, the faster it moves. Evidence that everything once started from a single, compact origin. If we rewind the clock, everything converges to that single point, about 13.8 billion years ago. It's as if the entire universe is a movie playing in reverse, all matter and energy collapsing back to the beginning. This is the heart of the Big Bang Theory. It's our best explanation for how the universe began, supported by evidence from cosmic background radiation, the distribution of galaxies, and the very elements that make up our world. Every atom in your body was once part of that tiny, fiery speck. The carbon in your cells, the oxygen you breathe, the calcium in your bones. All were forged in the aftermath of that first cosmic moment. You are not just in the universe is in you. The atoms that make up your body have traveled across billions of years and unimaginable distances, connecting you to the birth of everything. This connects you to the farthest star and the oldest galaxy. You are a living link in a cosmic chain stretching back to the dawn of time. Our story is one of transformation from a point of infinite density to the cosmos we see today. Over billions of years, that single point blossomed into stars, galaxies, planets, and eventually, life itself. Are you ready to see how it all unfolded? The journey from nothing to everything is filled with wonder, mystery, and discovery. Let's begin our journey at the very edge of existence. We'll travel from the smallest beginnings to the grandest scales, exploring how the universe grew and changed. The story of everything starts here. From this moment, the universe began its incredible expansion, setting the stage for all that would follow. The universe's birth is our shared origin. Every galaxy, every star, every planet, and every living thing traces its roots back to this single, extraordinary event. Let's see how it became the world we know, and discover the incredible journey from a single point to the vast, beautiful cosmos we call home. That single point is called a singularity, a place where our understanding of physics breaks down. At the singularity, all matter and energy were packed into zero volume, infinite density. There was no space, no time. These were born in the Big Bang. Einstein's theories guide us through cosmic history. But at time zero, the math falls apart. We get infinities, nature's way of saying we don't yet have the right tools. What happened at the exact instant of creation? Was it the true beginning, or part of a larger cycle? Some theories imagine a multiverse, others a cosmic bounce. We don't have all the answers, but the quest to find them drives science forward. From this instant, the cosmic clock starts ticking, and the laws of nature begin their work. The stage is set for the universe's most dramatic event, an explosive expansion. In the first split second after the Big Bang, the universe underwent a transformation so dramatic, it's almost impossible to imagine. In less than a heartbeat, everything we know, space, time, and energy, erupted into existence from a single, unimaginably dense point. But the universe didn't just expand, it inflated at a mind-boggling rate, far outpacing even the speed of light itself. This wasn't a gentle swelling, but a sudden, explosive ballooning of space. In a fraction of a second, the universe grew from smaller than an atom to larger than a grapefruit. This expansion was so rapid that distances between points in space stretched unimaginably fast, setting the scale for everything that would follow. What's truly astonishing is that it wasn't objects racing through space, it was space itself expanding, carrying everything with it. The very fabric of the cosmos was being pulled apart. This burst, known as cosmic inflation, explains why the universe appears so smooth, uniform, and flat when we look across vast cosmic distances today. Before inflation, everything in the universe was packed so closely together that any differences in temperature or density could even out, smoothing the cosmos. As inflation stretched the universe, it preserved that uniformity on a grand cosmic scale, freezing in the smoothness we observe today. It also made the universe appear flat, like an ant walking on the surface of a giant, perfectly smooth balloon. No matter where you look, the surface seems endless and flat. When inflation ended, all that pent-up energy was released, transforming into a hot, dense soup of particles, the building blocks of everything to come. The universe continued to expand, but now at a much slower, steadier pace, allowing matter to cool and begin to clump together. This brief, violent chapter of inflation set the stage for everything that would follow: the formation of stars, galaxies, and eventually, life itself. Without inflation, the universe would look chaotic and uneven, with no large-scale structure as we know it. Thanks to inflation, the raw ingredients for stars and galaxies were spread out evenly, ready to begin the next chapter of cosmic evolution. The cosmic story was just beginning, with the seeds of everything we see in the universe today already sown in those first fleeting moments. After the mind-bending expansion of inflation, the universe was left unimaginably hot and dense, a seething, glowing soup of fundamental particles. In this early chaos, quarks and gluons zipped around freely, unable to form anything stable. The temperature was so extreme that atoms, or even the building blocks of atoms, simply couldn't exist yet. As the universe expanded, it began to cool. This cooling allowed quarks and gluons to slow down and stick together, combining to form the first protons and neutrons, the basic ingredients of atomic nuclei. These tiny building blocks would one day make up everything in the cosmos, but the story was far from simple. For every particle of matter that appeared, a matching particle of antimatter was born alongside it. These pairs were like mirror images, identical in mass but opposite in charge. Whenever a particle met its antiparticle, they would collide and annihilate in a burst of pure energy, releasing powerful flashes of light that filled the young universe. For a brief but crucial moment, the universe was a cosmic battlefield, with creation and destruction happening at a staggering pace. Particles and antiparticles appeared and vanished in a chaotic dance, shaping the fate of everything to come. If this war had ended in a perfect tie, all matter would have been wiped out, leaving behind only energy, no stars, no planets, and no possibility for life to ever emerge. But something extraordinary happened. For every billion antimatter particles, there was just one extra matter particle, a tiny, almost unimaginable imbalance in the numbers. That minuscule surplus of matter survived the great annihilation, and from those leftovers, all the atoms in the universe were born. Over billions of years, these particles would come together to form stars, galaxies, and eventually, planets. Every star that shines, every planet that orbits, and every living thing that exists is made from the remnants of that ancient cosmic battle, a testament to the power of that tiny imbalance. We owe our existence to this 1 in a billion difference. Without it, the universe would be a lifeless sea of energy. The universe's remarkable fine-tuning, its precise laws and constants, made it possible for matter to survive, and for life to eventually emerge. Next, the universe takes another dramatic turn. It becomes transparent, allowing light to travel freely for the first time. For 380,000 years, the universe was a hot, dense fog of plasma. Light couldn't travel far without being scattered. Photons bounced endlessly off free electrons, making the cosmos opaque. As the universe expanded and cooled, nuclei captured electrons, forming neutral atoms. This event, called recombination, cleared the cosmic fog. Suddenly, light was free to travel across space. The universe became transparent. That ancient light, released then, still travels today. We see it as the cosmic microwave background, or CMB, the oldest light in the universe. The CMB is a baby picture of the cosmos, a fossil afterglow of creation. It fills the sky in every direction, stretched by billions of years of expansion. This light is key evidence for the Big Bang. It holds secrets about the universe's earliest moments. The stage was set for the first stars. After the universe became transparent, darkness reigned. The cosmic dark ages. Clouds of hydrogen and helium drifted in the dark, waiting for something to happen. Gravity began to pull matter together, forming denser clumps. Over millions of years these clumps grew, their centers, heating up under pressure. Eventually, temperatures soared high enough for nuclear fusion. Hydrogen atoms fused into helium, releasing energy. The first stars ignited, ending the darkness and flooding the universe with light. These stars were giants, burning hot and bright, but living fast and dying young. Their deaths came as spectacular supernovae, explosions that outshone entire galaxies. In their fiery ends, they forged the first heavy elements. The universe was no longer just hydrogen and helium. The cosmic dawn had arrived. The first stars changed everything. Their legacy would shape the future. The early universe was simple, just hydrogen and helium, but life needs heavier elements: carbon, oxygen, iron. These were forged in the hearts of the first giant stars. Through fusion, stars built heavier elements, up to iron. In their explosive deaths, supernovae created even heavier elements: gold, silver, uranium, and scattered them into space. These enriched clouds formed new stars and planets, including our own sun and Earth. The iron in your blood, the calcium in your bones, the carbon in your DNA. All were made in ancient stars. When you look at the night sky, you're seeing the factories that made you. We are stardust, direct descendants of the stars. This connection links us to the grand story of the cosmos. The universe's chemistry made life possible. Our journey began with a single point, a seed of pure potential. We watched it explode, inflate, and cool, setting the stage for stars, planets, and life. From stardust, new worlds and living beings emerged. On one small planet, life evolved to ask where it came from. We, the children of stars, have pieced together this cosmic story. The universe keeps expanding, driven by mysterious dark energy. Many questions remain. What is dark matter? What came before the Big Bang? Are we alone? Curiosity drives us to explore, to seek answers. From a single point to trillions of galaxies, this is our story. We are part of something vast and magnificent. The journey of discovery is just beginning.